JavaScript is an object-oriented programming language, just like Python, Ruby, C#, PHP, and many others you may have heard about. We've mentioned before that most things in your JavaScript code, like arrays or functions, are in fact objects. We also deal with objects themselves as actual data structures which aren't concealing their true identity. In this chapter, you'll start to soak in how objects function and how they interact. That's what OOP is all about. To start, let's look at the basic principles of OOP in real-world terms. I've been attending pottery classes at the local community center, and I made this pot. Actually, I made a few. All my pots share characteristics. They can be defined by their size, color, or shape. When creating a design in my head, my thoughts look like this. It would take me some time to write this down for every pot I want to make. In JavaScript, we have classes that let us simplify this task. I just create a pot class. Don't worry if you don't quite understand the new syntax here. For now, just keep in mind we can use this syntax to easily create new pots. I've actually started selling them too. Customers are able to pick the shape, color, and size for the pot. But I don't want them to decide if the pot will be decorated or not. This will depend on the time of day because I have a rule of not making any decorated pots after 3 p.m. I'll rewrite the constructor. Note that all the properties in the constructor are preceded with underscores. This means the fields are private and shouldn't be addressed or changed from outside the pot class. Protecting fields this way and hiding them from the world is an example of a basic OOP principle, encapsulation. The code won't break if I try to access private fields or methods from outside, but the underscore notation is a convention among JavaScript developers so that we all know if something needs to stay inside a class. However, I'll still allow customers to change the size of the pot if they suddenly change their mind. I've written a public method called setSize, and it will reassign the value of the private size field, just like this. Another important principle related to classes is inheritance. Imagine I've patented a pottery wheel. It has some special features, but it also shares features with regular pottery wheels. So we have a parent class, pottery wheel, and a child class called better pottery wheel. The child class will inherit everything from its parent, but it can also have unique attributes or methods. Very handy. And when I hire more potters for my growing business, I can easily produce pottery wheels of the same class for them. Users can make inquiries about each pottery wheel model. This is enabled with the getInfo method of the pottery wheel class. My patented pottery wheels can do the same thing, but there's a problem now. They have more features of their own. This means the getInfo method has to be slightly different. My child class has inherited its parent's properties in the constructor, but at the same time it has a getInfo method that's different from the parent class. This is the third great OOP principle, polymorphism. You'll learn much more about all the three principles, encapsulation, inheritance, and polymorphism in this chapter. We'll also talk about combining data and functionality inside objects, and this keyword you'll see in every JavaScript class. This is just the tip of the OOP theory iceberg, but even the basics of OOP aren't that easy to grasp. So take your time, and I'll get back to my pottery.